we're going to talk about the absolute value function. This is not, I don't know what I'm trying to say. So this is an example. It's not really a good introduction to the absolute value function. We've done absolute value before, and all we're really doing is finding out how far is something from something else. So if we're on the zero number line, if we're looking on the number line from negative infinity to positive infinity, and we're looking at 0, negative 2, the absolute value of negative 2 is 2 because it's 2 places away from 0. And that's really what we're doing as far as this goes. So when we're graphing these as functions, they're going to look a little bit different. And we just have to remember that because it's a distance, the absolute value, if it's negative on the inside of the absolute value, it's still going to be a positive number because we're just looking at the difference in the distance. It doesn't change a positive number to a negative number. It's not like an opposite thing. It's just how far away is it. And so it's always the inside of the absolute value sign always comes out to be positive. So it's asking us to graph this 1/4 absolute value of x. So I'm going to sketch this the best I can. I draw about as well on this as I do on the board. Our y-intercept is at 0. So we have a point right there. So if x equals 0, everything equals 0, so 0, 0. Let's go over to 4, because I know that if I put in a 4, it's going to make this a 1. So if we go over here to positive 4, then this is going to be at 1. So we have a point right here. And so my graph right here is going to look something like this. Okay, and previously if we were just to continue this, it would just keep going down in the negative. But let's look at, see if I can get the distance about right. Let's look at negative 4. If we plugged in a negative 4 into our function, the absolute value of negative 4 is also positive 4. So positive 4 times 1/4, that's still going to give me a 1. And so I'm going to have a point right here. And so it's going to look like this instead. It makes a V. And we just, of these graphs, the only ones that make sense, C does not make sense because they're negative. B looks a bit steep, so our slope looks wrong on that one. Let's look at this one. 1, 2, 3, 4. 4 lines up with 1. It looks like A is going to be the correct answer. This one, I don't know what it looks like. They gave 0, 1/4 is their center point, and that doesn't work either. Okay, so A would be the right answer for this one. But that's really all you have to do. You can get a graph that is going down, but not by changing the number inside to a negative. You'd have to change the outside to a negative. So if we were just really quickly, and I'll change my color for this, if we were to instead graph f of x equals negative 1/4 absolute value of x, okay, then what would we get? So the absolute value, again, we're going to just, we have a 0, 0. If it's 0, it's still 0. Let's do, here's negative 1, here's positive 1. Let's do positive 4. Okay, so if we go over to positive 4, then it's still positive 4. Positive 4 times negative 1/4 is going to be a negative 1, so it's going to be right here. And so our graph's going like this. And if we go over to negative 4, we're going to say that's about here. So here's positive 4. Here's negative 4. And if we plug in a negative 4, well, absolute value of negative 4 is positive 4. Positive 4 times negative 1/4 is a negative 1. And so we get the same graph flipped across the axis. So we can have numbers in the negative. It's just it's just going to be this a, this whatever our slope is on the outside. If that's negative, then it's going to flip it into the negative. Otherwise, it's going to be in the positive. The absolute value makes sure that our y values are positive. And then just really quickly, if we're looking at domain and range, what would our domain be? Well, our domain, we're not really restricted in our domain. We can plug anything into the x values, right? So our domain would be all real numbers, which that's one of the symbols for all real numbers. Or we could say negative infinity to positive infinity. And then our range, well, our range, we are limited. We cannot go, at least for this one, we can't go below 0. For this one, we can't go above 0. So our range for this one would be 0 to positive infinity. Another way to write that would be 0 is less than or equal to y, which is less than infinity. Okay, just different ways to write it. But you should hopefully realize that you're not going to get any of these numbers down below 0 for your range. Hope that was a helpful example.